everybody, and welcome to our second to last lecture here. So today is April 29th, 2020. And we will be moving on to section 5.3, which is labeled Okay, so it's labeled trigonometric functions of any angle, the unit circle. Okay, so in 5.2, we defined the sine, cosine, tangent, cosecant, secant, and cotangent of angles using triangles. However, we did not, we only can define it for trig functions defined for acute angles. Okay, so acute angle means an angle in between 0 and 90 degrees, or 0 radians and pi over 2 radians. Okay, so we would like to extend this to being able to find the trig functions of any angle. Okay, so the way we're going to do that is now we're going to work with circles and triangles at the same time. You may be thinking, well, we did talk about angles that weren't acute before, but that was in just section 5.1 when we were just introducing radians and degrees and things like coterminal angles and other things like that. So now we want to introduce the trig functions of these bigger angles. Okay, so let's, for example, consider an angle that's not an acute angle. So what if we had, what if we wanted to find the sine or cosine or tangent of this angle? Well, you can't draw a right triangle, because if we had, if you had an acute angle like this, if you wanted to find that angle, we could find all the trigonometric values by just drawing a right triangle here. But we could draw a right triangle here, but then we would be getting this angle here. And we want this angle. Okay? So we're going to figure out how to do this. So basically, this, remember, is a point. The endpoint of this line is a point x comma y. And what we want to do, actually, you can just pick any point on this line. This line could go forever, but you just want to pick some point on this line to start. Okay? So depending on the point you pick, you will get a radius or a distance from the origin. Remember, we know how to find that. The distance formula tells us that we'll call r the distance. R for distance, or it's a radius. Okay. So if you were to draw a circle here, the way you could find this circle's radius, or the distance from the center to the circle, is the distance formula. So you'd have the square root of x squared plus y squared. So for example, if this point were, I don't know, -1, 3, your r would be the square root of -1 squared plus 3 squared, or the square root of 10. Okay, so now that we've got that taken care of, then if r is defined by this, then the sine of your angle, the general definition, like keep in mind the definitions we learned last week work for acute angles, and they will give you the same answers if you use this definition here. Y over R cosine theta is equal to x over R. Tangent of theta is equal to sine over cosine, or y over x. And then you have all your reciprocals. So cosecant of theta would be r over y. And this is when y is not equal to 0. So for example here, and this is when x is not equal to 0. So let's just say, if you picked a point on the x-axis, then y would be equal to 0, so your cosecant function is actually undefined because you can't divide by 0. A point here at the origin, the reason that r can never be 0 is because if you just have a point here, there's no angle in between a point and its own self. So that's why r can never be 0. Secant of theta is equal to r over x, and cotangent of theta is equal to x over y. And of course this x can't be 0 here, and y can't be 0 here. Okay, so the sine and cosine functions are always defined no matter what. These ones you have to be a little bit careful. Alrighty, so now that we've got those definitions, let's try and find some values for a specific example. So let's say we have an angle theta, and we're going through the point that I drew up here in this example, -1, 3. And we want to find the angle between this line and the x-axis. Or we want to find all the trigonometric values of theta. So if we do sine theta, well, that would be equal to our y value. Remember, we already computed the radius of this point here. So r, I'll put this over to the side, r is equal to the square root of 10. So the sine would be 3 over the root 10. And remember, if you want to rationalize the denominator, that's 3 root 10 divided by 10. Okay, so now if we want to do the cosine of theta, we get x over r, so -1 over root 10, which is equal to -root 10 over 10. And tangent of theta is just x over y, or y over x, so 3 over -1, which is equal to -3. Okay, and if you want to find the cosecant, secant, and cotangent, you could just take the reciprocals of these. Alright, so continue on here. Okay, I'll just have to avoid that. So if we continue on, we need to talk about those cases where we're on the x and y axis. So if you wanted to find, for example, the cosine, or if you wanted to find the trigonometric values of theta equals 0 degrees or 0 radians, then you look at this, you look at your coordinate plane, and that's talking about the angle where you don't even move away from the the starting what does the book call it? Okay, so the book calls this the initial side. So when you're talking about angles in standard position, which we always are, the initial side is always the positive x-axis. So that's also 0 degrees means we're moving, our angle is 0, so we're just staying on the x-axis. So we're going to pick a point on the x-axis, and an easy one to work with is the point where x is equal to 1 and y is equal to 0. Okay, so that means that r is going to be equal to the square root of 1 squared plus 0 squared, or 1. And I'll show you, we can pick a different point and it'll work out the same. And it's because similar triangles will yield, a similar triangle is a triangle that has the same angles but the side lengths may be different. So it just matters about the angle, it doesn't necessarily matter about how big your radius is. So if I choose the point 0, 1, or 1, 0, and I want to find the sine of 0 degrees, then I'm just going to do the y coordinate, so 0 divided by the radius, so that's equal to 0. So now if I do the cosine of 0 degrees, then that's equal to the x coordinate over the radius. So that's equal to 1. And if I do the tangent of 0 degrees, well, we might have to be a little careful here because the tangent of 0 degrees is y over x. So it's actually 0 over 1, so that's equal to 0 as well. Okay, let's look at, however, let's go ahead and look at the cosecant of 0 degrees. Well, that would be, if it were correctly defined, to be 1 over 0, so, but you cannot divide by 0, so this is undefined. Okay, secant is just the reciprocal of cosine, so that's just the reciprocal of 1 is 1. And then the cotangent of 0 degrees is equal to 1 over 0, the reciprocal of this, so this is also undefined, because we're dividing by 0. Okay. Alright, so let's do the same thing, but let's do it. So you notice, first off, I want to make a comment about this. If I would have picked the point, any point on this x-axis, I could have picked 5, 0. Right? Any point on the positive x-axis is just, you can pick any x to be any positive number and y has to be 0. So the radius is just going to be the x coordinate, right? If I plugged in 5, it would be the square root of 5 squared plus 0 squared. So it would be the square root of 5 squared, which is just 5. And then you'd still get 0 over 5 is 0. And then you'd have 5 over 5 here, so you'd still get 1. And 0 over 5 here, so you'd still get 0. So it doesn't matter what point you pick as long as it's on the x-axis. And usually the point 1, 0 is pretty easy to work with. Okay, so keeping that in mind, let's say we wanted to do it for theta equals pi over 2. So first off, these are called quadrantal angles. So quadrantal angles are any angle who puts you on a coordinate, on the y coordinate or the x coordinate. So you could have 0, you could have pi over 2 radians or 90 degrees, you could have 180 degrees or pi radians, or you could have 270 degrees or 3 pi over 2 radians, or you could have 2 pi radians or 360 degrees. All those, and remember, there's coterminal angles too. So if you had, for example, 720 degrees, that's also a quadrilateral angle or quadrantal angle because it lands you on the positive x-axis. Okay, so another one is if we have theta equals pi over 2 radians. Okay, so that's going to put us on the y-axis, or which is 90 degrees, because this angle here is 90 degrees equals pi over 2. Okay, so let's pick a point. This time let's do 0, 1, since that's an easy one to work with. So then the sine of 90 degrees is equal to the y-coordinate over the radius. So again, the radius is equal to the square root of 0 squared plus 1 squared, which is equal to 1. So then this is equal to 1. Cosine of 90 degrees is equal to 0 over 1, which is equal to 0. And tangent of 90 degrees, if it were defined, is equal to the y over the x, or the sine over the cosine. Right, y over x, 1 over 0. So it's undefined. But the cotangent of 90 degrees is the reciprocal, 0 over 1, so this is equal to 0. The secant of 90 degrees is undefined, because you'd have to do 1 divided by 0. But the cosecant of 90 degrees is still 1, since it's a reciprocal of the sine of 90 degrees. Okay, so that's how you find the sine, cosine, the trigonometric functions of quadrantal angles that put you on the coordinates, or the x and y axis. So notice over here, though, if I want to do 180 degrees, I would pick a point. I'd pick -1, 0. So that would change all your values here. That would change the sign of all your values. Some of them would go from positive to negative. All right, so let's move on. So, so now we're gonna, again, the idea of coterminal angles was introduced in section 5.1. Coterminal angles, and remember, it's if you have degrees, it's sine of theta is equal to sine of theta plus n times 360 degrees. We're the radian mode. Remember, this is sine of theta is equal to sine of theta plus pi plus 2 pi plus n times 2 pi. Remember, n can be any integer you want. It has to be a whole number. So similarly, you can do cosine of theta is cosine of theta plus n times 360 degrees, and cosine in radian mode, it's cosine of theta is cosine of theta plus n times 2 pi. So basically that means, right, if I have an angle here, let's go, if this is my angle, then if I wanted to instead take the cosine of this angle where I go all the way around once, these two, the cosine and sine values will be the same, even though the angles are different. Okay, so let's do some examples here of using this, the coterminal angles. So find sine of 2,580 degrees. So we need to figure out how many times 360 goes into 2,580. So 360 times 1 is 360. Then you get 720. 1080. I believe it's 1440. And then 1800. And then the next one would be 2,160. And the next one would be 2,520. So it goes in 7 times. So this is 2,580 degrees is equal to 7 times 360. So remember, we said that it was 2,520. 7 times 360 is 2,520. So we also have to add on the remainder plus 60 degrees. So so now if I use my rule here, the sine of 2,580 degrees is equal to the sine of, or I haven't used the rule yet. Sorry. So it's equal to 7 times 360 plus 60 degrees, right? So that's just substituting 7 times 360 degrees plus 60 degrees in for 2,580. Now if I use the rule of coterminal angles, theta would be 60 degrees and n would be 7, and that almost looks like an 8. And n would be 7, and then 360 degrees is left over. So this is going to be sine, and then that's equal to just sine of theta. So this is just equal to sine of 60 degrees, which we know from last section to be square root of 3 over 2, I believe. Yep. Okay, so we used coterminal angles to find out the sine of this ginormous degree value. So what about a radian example? Cosine of 17 pi over 4. So we need to figure out how many times. So we need to figure out how many times 2 pi goes into 17 pi over 4. So remember, so 17 pi over 4 can be written as right, so if I did 16 pi over 4 plus 1 pi over 4, that's the same thing as 17 pi. So this 16 divided by 4 is equal to 4 pi plus pi over 4. Right, I just simplified this. So then this is equal to 2 times 2 pi plus pi over 4. So 2 pi goes into 17 over 4 twice. So in our radian mode, n would be 2, and then 2 times 2 pi plus theta is pi over 4. So we'd get cosine of 17 pi over 4 plus the cosine of, equals, so this is just substituting, it's pi over 4 plus 2 times 2 pi, and now I'm going to use the coterminal angle rule, and then this is going to be equal to the cosine of just pi over 4, which this is equal to the square root of 2 over 2. So that's how you can use the coterminal angles to find, bigger, or, values that input trig values of things that, of angles that go around the circle multiple times. Okay, so now let's talk a little bit about, so in the first section, in 5.2, all of our trig values were positive, because we have to talk about coordinates here. So if we were talking about acute angles, angles in between 0 and 90, the x is greater than 0 over here, and y is greater than 0 over here. If you pick any point x comma y in the first coordinate, remember it's coordinate 1, quadrant 1, quadrant 2, quadrant 3, quadrant 4. If you pick any xy pair in the quadrant 1, both of them are positive, so that means that all of the, by definition, sine, right, is, and r is always greater than 0. So sine of theta would be y over r, so that's going to be positive, since y is positive and r is positive. Cosine is also positive, and tangent is positive, and then the rest are as well. But what happens if we go over to quadrant 2, for example? Well, then we have x comma y, a point in quadrant 2, but x is going to be negative, and y is positive, because y is on the positive side, and x is on its negative side. So then sine of theta in this quadrant is equal to y over r, so it's positive, but cosine of theta is equal to x over r, and x is negative, so you have a negative number being divided by a positive number, so that's actually a negative number. So that also means that tangent of theta is equal to y over x is also negative. So you can you can do this for every quadrant. So the third quadrant, you have both of them are negative. So your sine and cosine will be negative, but your tangent will be positive because y over a negative number divided by a negative number cancels out the negative, so you get a positive. So you can do this for all four coordinates, just by identifying the signs of the x and y coordinate. Okay, so let's do an example problem. So if tangent of theta is positive and the cosine of theta is negative, what quadrant does theta lie? In what quadrant does theta lie? So, all right, let's think about this. So tangent of theta is equal to the the y coordinate over the x coordinate. And we know that, given by the problem, that that's positive. Okay? So the cosine of theta is equal to the x coordinate over the radius. And we know that that's negative. But the radius is a distance, so radius is always positive. So if the radius is positive and cosine of theta is negative, then we have, the only way we can get a negative number here is if x is negative. Okay? So that already tells us that if x is negative, we're either in quadrant 2 or we're in quadrant 3. So now we just have to figure out the sign of the y value. So the sign of the y value we can get from here, because if x is negative, and so we have a number divided by a negative number, we're getting a positive number. The only way we can get a positive number is if y is also negative, because then we have the negative from y and the negative from x canceling out to make a positive. See, if y cannot be a positive number, because then we would have a positive number divided by a negative number being positive, which doesn't work. So if x and y are both positive or both negative, then we have it's quadrant number 3. And people often use Roman numerals to define which quadrant they're in. Oh, that's a 6, isn't it? So quadrant 6. 4. Quadrant 4. 1, 2, 3, 4. Right. Okay, so that's how you can find, that's how you do that example. So now let's do another one. So if we have given that tan theta is equal to 3/2 and cosine theta is less than 0, find sine theta and secant theta. So let's start with the fact that, remember, tan theta is equal to, we know it's equal to 3 over 2, but we also know it's equal to y over x. So that's equal to 3 over 2. That doesn't necessarily mean that x is equal to 2 and y is equal to 3, because we could also have y being negative 3 and x being negative 3, and then we'd still get the 3/2. Okay, but we have another piece of information that cosine of theta is, right, cosine of theta is x over r, and r is always positive, and that's less than 0. So this means that x has to be negative. So if x is negative here, then y also has to be negative. Otherwise, there's no way you could divide y by x and get a positive number. So this means that, this does, however, mean that the point -3, sorry, -2 comma -3 lies on the line where that it lies on this line. So if we start our maybe here, I'll draw the point first. X is equal to -2. Y is -3. So this point lies on that line where theta, oops, I didn't even let you guys see that. So that means that the point -2 comma -3 lies on the line that that theta, the line that enters the terminal side, right? So if this is the initial side, and theta brings us all the way to the terminal side, the terminal line. So -2 comma -3. Okay, so that means that point lies on the line. So now how can we use this information to find out what secant of theta and cosecant, or sine of theta and secant of theta are? Well, we can use our definition. So first, if we take r, right, we can figure, if we choose this point -2 comma -3, we get -2 squared plus -3 squared, and that's equal to the square root of 4 plus 9, which is equal to the square root of 13. Okay, so r is the square root of 13. And now we can use our definition. So sine of theta is equal to the y-coordinate, so -3 over the square root of 13, which is equal to -3 root 13 over 13. Okay, so that would be the sine of theta. And the secant of theta is equal to the radius divided by the x value. So it's -root 13 over 2. Okay, so first thing we did was we took our information and we figured out the points x, a point x and y that lies on the line we're trying to, our terminal line. Then we can use these x and y coordinates to find r, and once we have r and the x and y coordinates, we can find all the trigonometric values for that angle. Okay. So now we're going to talk about a concept called a reference angle. Okay, so a reference angle is always an acute angle. So what you do basically, so if you have here's one example. So if you had your theta is in the your terminal line is in the first quadrant, or theta takes you to the first quadrant, then your reference angle, we'll call the reference angle theta prime. So that apostrophe means theta prime. So theta prime, if you're in quadrant 1, theta is equal to theta prime. So the idea really comes if you have angle that's not inside the first quadrant. So you always want it to be an acute angle. So let's say we have one, our theta is in quadrant, it takes us to quadrant 2. So then our reference angle is just bring it all the way down to one of the axes. So theta prime is going to be the angle that connects the terminal side to the y-axis, or the negative x-axis here. If we're in quadrant 3, so if theta is all the way down here, so this is theta, then the reference angle takes us to the negative y-axis. So the reference angle theta prime is that, is this angle here. And if we're in quadrant 4, so if the angle is all the way around here, so if this is theta, then the reference angle is just this leftover piece here. So it's always the acute angle that's kind of the opposite. It always, like this one is an acute angle, so we don't have to change, or we can use this as a reference angle. This one, theta, is not an acute angle because it's bigger than, it's in between 90 degrees and 180 degrees. So we want to find a reference angle, theta prime, and this one is in between 0 and 90 degrees, and same situation here. Okay, so let's do some examples where we find reference angles. I think this will clear up the concept here. So find theta prime. Find the reference angle for theta equal to 250 degrees. Okay, so first off, let's figure out what quadrant 250 degrees lies in. So remember, the angle, this is a 90 degree, right? Going from here to here is 90. This is 180 degrees, and this is 270 degrees. So 250 degrees lies in between 180. So it's 0 degrees, comma 360. So 250 lies in between 180 and 270, so it's quadrant 3. So if it's in quadrant 3, then we need to take, it's going to be somewhere, you know, if I draw a rough drawing here, then I want to find out what this angle is here. Right? So I would need to do, if this angle is 250 degrees, and I want to know theta prime, I know this angle too, I could do theta prime is equal to 270 degrees. This angle all the way here, right? That's 270. And then I subtract the 250, which leaves me with 20 degrees. So the reference angle would be 20 degrees. Because I have to take 270 and subtract my I'm sorry, hold on. I think I may have messed up. Yeah, I did mess up. So here, I actually want to redefine what, so this one was quadrant 1. So this is back to my previous page of notes. This one was quadrant 2. This one's quadrant 3. This one's quadrant 4. So in this one, I defined the reference angle incorrectly. The reference angle for quadrant 3 should be this angle here, rather than the one I just erased. Okay, so we were looking for the, I was looking for the wrong angle. Okay. So instead of looking for this angle here, we need to be looking for this angle, theta prime. So now we want to actually take our angle, which is 250 degrees, all the way to here, and subtract 180 degrees, because we would then be subtracting this angle. There. So instead it's instead 250 degrees minus 180 degrees. So that's equal to 70 degrees. So this one here, 70 degrees. Okay. So what about if theta were equal to, this is a radian example now, 3 pi over 5. So we got to figure out what quadrant that's in. So if I draw my picture here, I get this is 0 radians, this is pi over 2 radians, this is pi radians, and this is 3 pi over 2 radians, and this is 2 pi radians. So 3 pi over 5. So, well, I could write this as 6 pi over 10. So it's definitely bigger than, it's bigger than a half pi, because a half pi over 2 is 5 pi over 10. But it's not as big as a full pi, because pi is equal to 10 pi over 10. So it's going to be in quadrant 2. So it's going to be somewhere right there. So for quadrant 2, remember our picture for the reference angle, quadrant 2, is we want to find out the angle remaining. So our theta is this angle here, and we want to find out what the angle is between this line and the negative x-axis. Okay, so we are searching for theta prime. And this is theta equal to pi over 5. Okay, so we can take, if we have our, we know that this angle from starting at the initial spot and going all the way over to the negative x-axis is pi radians. So if we take pi, this big angle minus our theta angle, we'll be left over with theta prime. Right, so we get pi minus 3 pi over 5, which is equal to 2 pi over 5. Right, this is 5 pi over 5. So that is your reference angle. Okay, so let's do one that's kind of tricky. So if we have, for example, theta equals 5.75. Okay, so one thing I'd like to say first is if they give you an angle that does not have a degree marker up on the top right, that means they're talking about radians. Okay, so this is an angle in radians. So this is going to be tricky because we don't know what quadrant this is in. 0, 2 pi, pi over 2, pi, and 3 pi over 2. So we kind of have to approximate. So remember, pi is about 3.14. So that would make this 2 pi equal to about 6.28. So, and if you go halfway in between these two, this is approximately equal to 4.71. Okay, so based on that information, we know that the angle 5.75 lies somewhere in the fourth quadrant, because it's bigger than 4.71 but less than 6.28. So we're going to be searching. This is the angle we have, theta, and we're going to be searching for theta prime, right? Because if it's in quadrant 4 is this picture down in the lower left. So we need to search for theta prime here. Okay. So if I take the angle all the way around, so that's a 2 pi angle. So if I take 2 pi minus theta, I'll be left over with theta prime. So 2 pi minus theta equals theta prime, because it's in quadrant 4. So it's 2 pi minus 5.75, which is equal to about 0.53 radians. So that's how you find the reference angle for that. So a little summary: if theta is in quadrant I'll make a little table here. Quadrant 1, 2, 3, and 4. Then theta prime is equal to just, that's q prime, not theta. Theta prime equals, if it's in quadrant 1, it's theta. If it's in quadrant 2, it's pi minus theta. So these are in radians. If it's in quadrant 3, it's theta minus pi. If it's in quadrant 4, it's 2 pi minus theta. So if theta is in quadrant 1, 2, 3, and 4, theta prime equals the following values. Okay, so now we're going to do some examples about why these reference angles matter, or using the reference angles. So this example is find sine of 1320 degrees. Okay, so first we got to find out the coterminal angle that lies in between 0 and 360 degrees. So remember, it's 360, 720, 1080, and then 1400. So it's 360 fits into 1323 times. So this is equal to the sine of 3 times 360. So 3 times 360 is 1080, and so the remainder here, I need to add 240 degrees on here. So this is the angle we want to work with. So by the coterminal rule, this is the sine of 240 degrees. So, if we draw that on a coordinate plane here, 240 degrees, this is 90 degrees, 180 degrees, 270 degrees, and 0 degrees, or 360 degrees. Okay, so essentially, you went around the circle 1, so that's 360, 720, 1080, and then you go around 240 more, which is about there. So 240 is our theta. So we need to find out, the next step to finding sine of 1320 would be to find the reference angle. So if I now find the reference angle of 240, well, 240 degrees is in quadrant 3. So that means if I look at my table up here, it's in quadrant 3, so I need to take the angle minus pi, but we're in degrees, so it's the angle minus 180 degrees. So it's 240 degrees minus 180 degrees is equal to theta prime. So that's equal to 60 degrees. Our reference angle is 60 degrees. So this angle right here is 60 degrees. Okay, so now if I keep moving forward here, let me redraw our picture here. So we've so far figured out the coterminal angle in between 0 and 360 degrees and the reference angle. So the coterminal angle is 240 degrees. And the reference angle is 60 degrees. Okay, so we need to find, remember we're keeping in mind that sine of 1320 degrees by the coterminal rule is sine of 240 degrees. So, we also know that this is in quadrant 3. So I could find the sine of just the reference angle, sine of 60 degrees. And we know what the sine of 60 degrees is from last section, or just, you can use your definitions here. That's the square root of 3 over 2. But remember, sine of theta, by definition, is it's y over r. Okay, so if we're in quadrant 3, this means that x is negative and y is negative. And if r is positive, so sine of 60 degrees is a positive number. Sine of 60 degrees is square root of 3 over 2, but since we're in the third quadrant, we got to change it to negative. So it's got to be negative sine of 60 degrees. Because we're not trying to find the sine of 60 degrees, we're trying to find the sine of 240 degrees. So the sine of 60 degrees would be up here. And that would be positive root 3 over 2. But the sine of 240 degrees brings you all the way down over into quadrant 3, so you need to make this a negative because we're in quadrant 3, and the y value has to be negative. So this is equal to the sine of 240 degrees, which again, this is equal to the sine of 1320 degrees. Okay, so these are a little tricky, so let's go ahead and do a couple more of these examples. So let's find the tangent of 330 degrees. So this one's already in between 0 and 360 degrees, so we just got to find out what quadrant it is. There's no reason to find our coterminal angle in between 0 and 360 degrees because it's already in between 0 and 360 degrees. So remember, this is 0 or 360 degrees. This is 270 degrees, 180 degrees, and 90 degrees. So we already know that it lies in quadrant 4. It lies in between 270 and 360. So now we find the reference angle. So the reference angle, since we're in quadrant 4, if I look back at that table, we're in quadrant 4, so I need to take theta pi, so quadrant 4, so then the reference angle, theta prime, is equal to 360 degrees minus 330 degrees. Oops. That's this angle here. Right, so that's going to be equal to 30 degrees. Okay, so if we take the tangent of 30 degrees, remember, we also should remember what the tangent definition is. It's y over x. So in quadrant 4 we have x is positive and y is negative. So if we want the tangent is going to be, the tangent of 330 degrees is the same thing as tangent of 330 degrees is equal to the tangent of its reference angle, 30 degrees, except because x is positive and y is negative, we have a negative number divided by a positive number, so we need to put a negative out front there, just like we did up here with the sine. Okay, so this is going to be equal to the tangent of 30 degrees, 1/2 over the square root of 3 over 2. So it should be 1 over root 3, and then our negative out here. The tangent of 30 degrees is 1 over root 3, and then we have to have the negative, because the negative is here. So this is equal to negative root 3 over 3. Okay. All right. So let's do one more. So we've got this is going to be a radian example as well. So find the secant of 59 pi over 6. So using our reference angle, we're going to figure out how many, we first need to find the coterminal angle in between 0 and 2 pi. So find coterminal angle between 0 and 2 pi. Okay, so how many times does 2 pi go into 59 pi over 6? Or in other words, let's first simplify this fraction. So 6 times 6 times 6 times 9 is 54. So this is secant of 59 pi over 6 is equal to the secant of 54 pi over 6 plus 5 pi over 6. Okay, so this is equal to secant of 9 pi plus 5 pi over 6. So the reference angle, careful, the coterminal angle is not 5 pi over 6, it's rather, remember we have to write this as secant of, so now this is, we have to write it in multiples of 2 pi. Right, so we have to take, I'm just rewriting 9 pi as 8 pi plus pi, so this is equal to secant of 4 times 2 pi, where 4 is n, plus, this is going to be 11 pi over 6, because pi is 6 pi over 6, and then you add these two together. So our coterminal angle, by the coterminal angle rule, this is the same thing as the secant of 11 pi over 6, which is 11 pi over 6 is just in between 0 and 2 pi. So 11 pi over 6, so now we have to figure out what quadrant that's in. That's 0, 2 pi, pi over 2, pi, and 3 pi over 2. So it's 11 pi over 6 is it's in between 3 pi over 2 and 2 pi, and you can see that because 3 pi over 2 is the same thing as 9 pi over 6. Just multiply the numerator and the denominator by 3. Okay, and then here 2 pi over 6 is equal to 12 pi over 6. Multiply the numerator and the denominator here by 6. So 11 pi over 6 lies in quadrant 4. So theta equals 11 pi over 6 is in quadrant 4. Remember that script E means in. Okay, so now the next step is, remember, to find the reference angle. So since we're in quadrant 4, our table says that the reference angle theta prime is equal to 2 pi minus our coterminal angle of 11 pi over 6. So this is equal to 2 pi minus 11 pi over 6, which is equal to, remember 2 pi is 12 pi over 6, so this is just going to be pi over 6. So our reference angle is pi over 6. So now we need to figure out, so the secant, the definition of secant is equal to the radius over the x value. And in quadrant 4, the x value is positive and the y value is negative. So the x value is positive, so we have a positive number over a positive number, so the secant, so that's why we're going to want to keep the actual secant value, because this, we don't need to add a negative because in quadrant 4 x is positive. So secant of 11 pi, secant of 11 pi over 6 is the same thing as the secant of just pi over 6. So yeah, because we're in quadrant 4, the secant is positive because the radius is positive and the x value is positive. So we're going to keep that positive value. So the secant of pi over 6, well, the way you can figure this out is the cosine of pi over 6 is square root of 3 over 2, so this is going to be 2 over the root square root of 3. And if we rationalize the denominator, this is equal to 2 root 3 over 3. Okay, so those are 3 examples of how to find angles of arbitrary, or trig values of arbitrary angles using reference angles and coterminal angles. Okay, so finally I want to talk about the unit circle. So people use the unit circle. The unit circle is just the circle where r is equal to 1. So for example, this point here is 1 comma 0. This point is 0 comma 1. And this one, negative 1 comma 0 and 0 comma negative 1. So there's an explanation for all this on page 551 and 552, but I'll just tell you right now. I'm going to draw some angles here. So there's 3 angles here. So this one is pi over 6. That's this angle. This angle is pi over 4. I don't know if you guys can see that very well. And then the angle from here to here is pi over 6. And these x and y coordinates of these three points here, so the x coordinate for this one, well, it's square root of 3 over 2 comma 1/2. You've seen these values before. The x and y coordinate for this one is root 2 over 2 comma root 2 over 2. And the x and y value for this one is 1/2 root 3 over 2. So what I basically drew is this figure on page 552, the picture of the unit circle. Okay, so notice that they give you the angles 30 degrees and in radians, and they give you the x and y coordinates. So let's just take a look at the cosine and sine values here. So remember, sine, for example, of theta is equal to the y value over the radius. The y value over the radius. But on the unit circle, the radius is equal to 1. So if the radius is equal to 1, then the sine of theta is equal to just the y value. So it's really nice on the unit circle, there's a way you can remember this. If you can remember these 3 values, root 3 over 2, 1/2, and root 2 over 2, and you can remember, you can keep in your head which quadrant the x and y coordinates have to be positive and negative in, you can remember all of these values of sine theta and cosine theta and tangent theta because, for example, like I just said, the sine of theta is just the y coordinate on the unit circle. So the sine of pi over 6 is 1/2. The sine of pi over 4 is square root of 2 over 2. The sine of 60 degrees or pi over 3 is square root of 3 over 2. Now if we move on to quadrant 2, then the x value is negative. So for example, the cosine of 2 pi over 3 is just the x value here, so it's a negative 1/2. Okay, and it goes on and on like this. So that's what's nice about the unit circle, is you can just remember the x and y coordinates, and then you've got the sine, cosine, tangent, and cosecant, secant, and cotangent values. So, for example, let's find sine of 5 pi over 6. Well, so 5 pi over 6, let's look at our unit circle here. So 5 pi over 6 is right here. That's this angle here. So if we want to find the sine of it, it's just 1/2 because it's just the y coordinate that's associated with it. So it's equal to 1/2. Okay, and you can do that for all the, and then for example the cosine of 5 power 6 would be negative root 3 over 2. Alright, so that's all I have to show you today. You may want to, if you have, have the book handy, looking at that unit circle will be very helpful for the homework on this section. Alright, so we have one last lecture, and then our final is on Wednesday of next week. And I will email you with some information about that.